Let's recap about what we discussed in the smart grid architecture. First, we discussed that the smart grid architecture is a layered architecture, and we discussed that there are five principal layers, that is component layer, communication layer, information layer, functional layer, and the business layer. And we discussed that the component layer is nothing but the virtualization of the devices which we have in the power system network. Then these virtualized component acquire data with the help of physical devices. Then the data is sent to the upper layers using various communication protocols. Then at the information layer, the data model is utilized to standardize the data which we have received from the component layer, and then it is being consumed by the functional layer as well as the business layer. We also discussed about the NIST architecture on smart grid, which includes distributed energy resources also. And we saw that the NIST domains, that is market, operations, service provider, customer, transmission, distribution, and generations, are utilizing the five layers which we discussed previously to share the data across the domains. And we also discussed that the devices which are there at the customer level or maybe at the transmission or distribution level, they exchange the data with various applications which are there in the operations as well as service provider domains and maybe the markets domain for the efficient operation of the power system network. Here we also discussed that the enterprise service bus is required for the data integration between the OT application as well as the IT applications. Then we discussed about the smart grid communication layer, and we saw how the data travels from, say, smart home to the control center, or maybe from the substation to the control center, and so on. So, what are the various technologies we use for communication? That also we discussed. So, for example, at house level, we utilize house area network, and in the field, we use field area network, and the wide area network and the neighborhood area network is utilized for longer distance communication. Then we also discussed about the various communication technologies utilized at various layers. Say, for example, in house area network level, we have technologies such as Zigbee, Wi-Fi, and so on. Similarly, in the neighborhood area network, depending upon the type of data is being transmitted, we utilize either power line carrier communication or WiMAX or IEC 62056 or maybe the cellular network. Similarly, in wide area network, where the data is communicated over long distance, we use either synchronous network or maybe wave division multiplexing or asynchronous transfer mode or the MPLS and so on. At the enterprise level, we have various standards for the data communication, say IEC 61970, 61968, which are commonly known as Common Information Model. We also use web services, multi-speak, or maybe message bus for the communication between various OT applications and IT applications at the enterprise level. And then in the external world, we have standard IT protocols for the data communication. So depending upon the requirement, the particular communication technology is being utilized. Now, then we discussed about the smart grid information layer. We discussed that this is the standard framework is being utilized for merging the information technology and the operational technology. We also discussed that the data received at the field is first communicated to the high-speed service bus for real-time data operations, and then the OT application receives that data, processes it, and then it is shared with the enterprise service bus for the data to be consumed by various IT applications such as customer information system or ERP or GIS, AMI, and so on. And we also discussed that the information architecture, which we are seeing in this slide, is not only for electricity, but also it is equally applicable for gas as well as water. So, in a smart city concept, this kind of architecture is very common where we integrate all the services in a single information model. Then we discussed about the smart grid service oriented architecture model, where we discussed that the data which is not in a standard format needs to be first converted into a standard format with the help of various adapters. So at the high speed service bus, we use high speed service bus adapter to convert data into a standard format and vice versa. And then if the data needs to be sent from OT to IT, the SOA adapter is used to convert local data into a standard data format, and then it is being shared by the enterprise service bus with various IT applications. Then we discussed IC 62357, that is the smart grid model for information exchange, and we saw how the data travels from the field up to the enterprise level. The data is packed into various protocols and then shared with the communication front end, which is there at the control center, and then it is being shared with various OT applications, and the output of OT applications are are converted into a standard data format using common information model, and then this information is shared with the enterprise service bus. Then we discussed about the smart grid functional layer, and we saw the advanced EMS architecture, which is part of smart grid functional layer, and we saw how the data travels from field via communication network to the functional applications. So we saw how functional applications absorb the data, process it, and then this information is being shared to the business layer. Then finally, we discussed about the smart grid functional as well as business model, where the functional as well as business layers are blended in such a way that the information which is being shared by the functional layer is used by business layer to share with the external world. Now from next video onwards, we will start our discussion about the smart grid measurement. We will discuss about the phasor measurement unit, smart meters, wireless sensor network, Internet of Things, and the geographical information system.